Compressed air is often a major energy user in food processing facilities. There are three common ways food processors can reduce their energy use associated with compressed air. Compressed air is generally an inefficient method of providing power. In spite of this, it is often worth the trade-off because of the benefits related to pneumatic tools, pneumatic controls, and where electric motors or controls may be explosion hazards. Eliminating inappropriate uses for compressed air should be a starting point to reduce overall use. Although using compressed air is warranted in some situations, there are several inappropriate uses that should be identified and quickly eliminated. A few of these are drying, process cooling, padding, atomizing, and idle or abandoned equipment. A more comprehensive list can be found by reviewing the Department of Energy's compressed air tip sheet. The recommendation to eliminate or reduce compressed air usage has an average annual savings of about $5,400. It's suggested to walk through your facility and identify all compressed air uses. If possible, also list the flow and pressure requirements for each use. When inappropriate uses are identified, consult with a compressed air system specialist to find other equipment that could be more appropriate and energy efficient. The next recommendation we will talk about related to compressed air is to eliminate leaks in the system. This has an average annual savings of $8,000. If you have a compressed air system that has not been inspected in the last 3 months, consider inspecting it and implementing a quarterly leak detection program moving forward. Fixing leaks once is insufficient because leaks develop continuously, so having a regular schedule to perform maintenance is key. The U.S. Department of Energy teaches that a leak detection program should include identification and tagging, tracking, repair, verification, and employee involvement. A reasonable leak target for small facilities is 5 to 7%, for medium facilities is 7 to 10%, and for large facilities is 10 to 12%. For a system in constant operation at 0.05 kilowatt hours, with 100 psig pressure, a leak 1/16 inches in diameter can cost $500 per year, and a leak 1/8 inches in diameter can cost $2,000 per year. A $100 per year sized leak cannot be heard or felt. A $300 per year sized leak can be felt but not heard. This is why the use of an ultrasonic leak detector is recommended to locate as many leaks as possible and fix them in a timely manner. Note that leak detectors cost between $1,000 and $3,000, depending on the features. Air compressors have an intake location where air is taken and routed to the compressor. If this air is hot, it is less dense, so the compressor has to work harder to increase the density to the desired level. Since cold air is denser, installing the compressor air intake in a cool location reduces the effort the compressor has to exert in order to get the air to the desired pressure. This strategy was recommended 191 times by industrial assessment centers nationally and has an average annual savings of $3,900. When selecting an intake location, it's important to verify air quality by checking that the location of the entry to the inlet pipe is as free as possible from ambient contaminants, such as rain, dirt, and humid discharge from a cooling tower. The Department of Energy suggests reducing the intake temperature by locating the intake filter outside the room or building. If it is outside the building, it's particularly important to take into consideration the ambient conditions. In some cases, these conditions will outweigh the need to access the location in inclement weather conditions, specifically on a rooftop. In essence, it is more important to have easy access to the intake filter than it is to bring in air that is a little bit cooler. Follow along in the next video to learn about how heat recovery could save you money.